So we have seen the electrostatic due to the circular disk, right? If this is the disk, I am giving you the formula once again. The distance is x, the radius is r, right? At this point, the electric field is what? You have to remember the electric field at this point. If this angle is theta, right? This is the theta, and the surface charge density is sigma coulomb per meter square. So electric field is sigma upon 2 epsilon naught 1 minus cos theta. You have to remember, right? So this is the easiest way to remember this formula. What is the cos theta? This is the cos theta, right? If this is r, this is x, this is root over r square plus x square. So the cos theta is sigma upon 2 epsilon naught 1 minus base upon hypotenuse. So you can remember the formula in this way. Is it clear or not? Okay. So here what the conclusion may be drawn. Listen one thing. If you increase the radius, right, for electric field, I am writing the next, the electric field due to infinite plane sheet, having surface charge density sigma. You understand? Having surface charge density sigma. What does it mean? Infinite plane sheet mean if this ring increases its radius like this, if this is the initial ring, so this is the disk. If you increase the radius, right? If the radius is tending to infinity, then it become what? It become infinite sheet. You understand or not? Right. So when r tending to infinity, therefore at this point at distance x, the electric field due to this infinite large sheet equal to what? Sigma upon 2 epsilon naught. Sigma is the surface charge density, coulomb per meter square, and 1 minus, this is x upon infinite plus, right? R is tending to infinity upon x. So 1 upon infinity is 0 is equal to sigma upon 2 epsilon naught. You have to remember this, right? What you have to remember, listen one thing. The sheet is infinite. If this is the sheet, right, it tending to this side infinite, 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 and this is uniformly charged, right? It is not necessary to be, right, circle, because at infinity it may be of the any shape like this, right? So what is the electric field at distance x? The electric field is uniform. It does not depends upon the distance x. The electric field, whether at this point, right, the electric field is nothing but sigma upon 2 epsilon naught. You have to remember this, right? If it is positive, the electric field is away from the sheet. If it is negative, the electric field will be towards the sheet. That's it. You understand? Right? Copy this. So this is the electric field due to the infinite sheet. You can write one more point. It is independent of distance, right? And it is uniform the uniform electric field, right? I'm making the figure due to this circular and the infinite sheet, right? For example, listen one thing. If this is the sheet, this is the 3D view, right? The sheet may be defined as like this, right? This is the sheet up to infinity, right? What do you mean by sheet? Listen one thing. If this is the sheet, right, the sheet is up to infinity, right, left, right, the infinite sheet from here to infinity, everywhere, right? This is the side view, and the surface charge density is sigma, You understand? This is the sheet having sigma coulomb per meter square, surface charge density, right? So at this point, any point at distance r, the electric field is what? Sigma upon 2 epsilon naught. Is it clear or not? Also, if you look this side, the electric field at this point is also, right? This is the sheet having surface charge density, surface charge density is sigma coulomb per meter square. So this side electric field is what? Sigma upon 2 epsilon naught. And this electric field is what? The electric field is like this, away from the sheet, right? Everywhere, 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 like this. In this side also, everywhere. The electric field is away from the sheet, away from the sheet. Uniform. Is it clear or not? Sigma upon epsilon naught. For example, if this is the negative sheet, right? If the sheet is what? Having the negative surface charge density minus sigma coulomb per meter square. So at this point, the electric field is towards the sheet and sigma upon 2 epsilon naught. This side also does not depends upon the distance. Whether this point, everywhere the electric field is constant, and for this sheet the electric field is sigma upon 2 epsilon naught, right? It is towards the sheet, towards the sheet, towards the sheet, towards the sheet, does not depends upon the distance. Is it clear or not? Right? Copy this. This is for negative positive charge, right? And this is for the negative charge, the infinite sheet I am talking about. Copy this. So let's see how to solve the question based upon the infinite plane sheet. For example, right, this is not the line charge, this is the sheet I told you, right? The sheet is like this and the charge is placed on the surface, right? It is extended from here to infinity everywhere, right? So although we are using the straight line, for example, this is the infinite sheet. The surface charge density is what? Say sigma. At distance d, the another sheet is placed over there, right? Having surface charge density, say 2 sigma. You understand? For this sigma, for this 2 sigma. And now we have the 3 points. This is the point A, this is the point B, this is the point C. Is it clear? Suppose this distance assumed to be d, this distance assumed to be the d, this distance assumed to be the d, this distance assumed to be the d. Getting or not? So you have to find the electric field at point A, B and C. Here at this point the electric field you have to find. If the two sheets are placed parallel to each other, the infinite sheets are placed having the surface charge density sigma and 2 sigma. At the point A, B, C, you have to find the electric field. This is the question. Think about this. Try this. So let's see how to solve this question. Right? Listen. If this is the sigma, this is the plate 1, plate 2, or the sheet 1, sheet 2. Because of this sigma, the electric field is away. Here the electric field is E1, which is sigma upon 2 epsilon naught due to this sheet. This is also the positive sheet. So due to this sheet, the electric field is away from the sheet, and here the electric field is E2 is equal to sigma upon 2 epsilon naught. So at this point, the electric field at point A will be equal to sigma upon 2 epsilon naught plus, right, 2 will cancel out, or you can write 2 sigma upon 2 epsilon naught. So what will be the electric field at this point A? It is the sum of 2 sigma, this is the 3 sigma upon 2 epsilon naught is the electric field at this point A. Is it clear or not? Now if you consider the B point, because of this sheet, the electric field, this is the first sheet, the electric field is away from the sheet, and this is the sheet, the electric field is away from the sheet. Is it clear or not? What is the E1? Because of this, the E1 is sigma upon 2 epsilon naught. Because of this, the electric field is sigma upon 2 epsilon naught. But both are in opposite direction. Therefore, the electric field E2 is greater than E1. So what will be the electric field at point B? The net electric field at B, right? This is the electric field at B will be equal to what? E2 minus E1. E2 minus E1. This is E2 minus E1. Here the electric field at A was equal to E1 plus E2. This is what? E1 plus E2. The E2 is what? Due to this 2 sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught. So the answer is sigma upon 2 epsilon naught. And what is the direction of the electric field B? The electric field B is in this direction, right? Now, if you want to write the electric field at this point C, listen, the electric field does not depend upon the distance due to this sheet. If this is the first sheet, the electric field due to first sheet is away from the right, away from this point. This is the E1, right? And this is the second sheet. The electric field is away from the sheet. This is the E2. The E1 is due to sigma upon 2 epsilon naught. It is 2 sigma upon 2 epsilon naught. So the electric field at point C is equal to what? E1 plus E2. Mean E1 plus E2. Again, this is sigma upon 2 epsilon naught and 2 sigma upon 2 epsilon naught. All right. So this is 3 sigma upon 2 epsilon naught is the electric field at point C. Right. This is at point C. This is at point B. The direction is towards this side. This is the electric field at A, and the direction at this point is towards left, towards left, towards right. Right. So these are the 3 electric field at point A, B, C. Right. Copy this. So this is the plus sigma. I am taking one another example. If suppose this is the infinite sheet having the surface charge density sigma plus sigma coulomb per meter square, right? Whether it is plus or not, it is you have to assume this the positive, and this is the surface charge density having the surface charge density minus sigma coulomb per meter square. Again, there are 3 points. This is point A, B, and this is C. The distance is D. This is D. This is D. This is also D. Right? This is sigma. This is minus sigma. Can you find the electric field? You have to find the electric field at point A, B, right, and C. Right? This is the question. I think you can do in this way. Right? Copy this first. So tell me, listen one thing. If this is the positive sigma, this is the plate 1, plate 2, or sheet 1, sheet 2, you can assume. Because of sigma, the electric field at this point is away from the sheet. And the value is what? Sigma upon 2 epsilon naught. And because of this minus sigma, the electric field is towards the sheet. This is E2. Answer is here. You have not to write the minus sigma. The minus shows only the direction is towards this. So what will be the electric field at point A? The electric field is E1 minus E2, and this is what? Right, you can write below this, right? Sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught is equal to 0. So here in this region the electric field is 0, and any point the electric field will cancel out, right, from each other. This is sigma, this is minus sigma. In the same way, at this point, because of this positive charge, the electric field is away from the sheet, and because of this negative sheet, the electric field is towards the sheet. Is it clear or not, you tell? So what is E1 and E2? Again, because it is sigma and minus sigma, you have not, because of this sigma, the electric field is sigma upon 2 epsilon naught. And because of this E2, you need not to write the minus sigma, only the magnitude I am writing. So the electric field at C, right, is again nothing but E1 minus E2. Both are equal. Sigma upon 2 epsilon naught, sigma upon 2 epsilon naught is equal to what? This is 0. Is it clear or not, you tell? Now we come to the midpoint, right, like this. This is the sigma plus sigma. The electric field is away from the body, away from the sheet. Because of this minus sigma, at this point, the electric field in the same direction. So at this point B, this is the B point, the electric field is E1 plus E2. The E1 is sigma upon 2 epsilon naught, sigma upon 2 epsilon naught. No need to write the minus sigma, I am repeating again. The minus shows only the direction. We are writing the magnitude. When you will calculate, the electric field between the plate is sigma upon epsilon naught. This side is 0, this side is 0. Right, I'm making the figure once again because of this charge distribution on the sheet. It constitutes the parallel plate capacitor. The next chapter, we will get this. If this is the plus charge over there, this is the minus charge over there, right? This is the plus sigma surface charge density. This is the minus sigma surface charge density. So the electric field between the plate, right? The electric field between the plate is like this, right? And what is the electric field between the plate? Say sigma upon epsilon naught. You must understand, although we will repeat in capacitor it once again. And this side, the no electric field, this side, the no electric field. Therefore, if the two parallel plates having the equivalent opposite surface charge density, the electric field is confined between the plate and the value is sigma upon epsilon naught. How does it come? I had explained, right? So copy this and right, we will see the next example. So I'm writing a very good example. For example, this is the infinite sheet, right? The infinite sheet. The infinite sheet tending from position point P to infinite in the space like this, right? It is tending to infinity this side, it is tending to infinity this side, it is tending to infinity this side like this. Is it clear? The surface charge density is sigma coulomb per meter square, right? And now we are making a hole. The hole is made. The surface charge density is everywhere, but this is the hole. Is it clear or not? And the radius of the hole is assumed to be the A. And if this distance is what? Say A. Is it clear or not? So you have to find the electric field, at point P as shown in figure. As shown in figure. All right, this is the question. There is an infinite sheet, surface charge density is sigma. There is a hole or the disk of the radius A is removed from it. So what is the electric field at this point P? The radius of the disk is assumed to be A, at the distance from the sheet, right, is A. Right, try this, copy this. Let's see how to solve this question. To find the electric field due to this sheet having some disk removed, right? First you will write the electric field, right? This is the surface charge density, all right, like this, like this. If it is the sigma coulomb per meter square, due to this, what is the electric field? Does not depend upon this distance A. If the sheet is complete, right, and tending to infinity, so what will you write the electric field over here? Due to the sheet, the electric field is sigma upon 2 epsilon naught. Is it clear or not, you tell? Now listen one thing, some portion is to be removed. What portion? A disk of radius A is to be removed. So if you consider this is the disk having the surface charge density sigma, right, which is removed. So at this point, at distance A, this is the radius A. Because of this sigma, what was the electric field? The electric field was sigma upon 2 epsilon naught 1 minus cos theta, right? If this is the radius A, What is the theta? Here, the tan theta is what? Say perpendicular upon hypotenuse, perpendicular upon base is equal to 1. So theta is what? 45 degree, right? It is tan 45. Is it clear or not? So the electric field due to this sheet is 1 minus cos 45. Cos 45 is what? Say it is 1 by root 2. So this is the electric field due to disk, and this is due to infinite sheet, Is it clear or not, you tell? So if this is the electric field due to the complete sheet, you have to remove this portion. So to find this electric field due to this sheet having some removed disk, what you have to do? You have to write the electric field due to the complete sheet minus due to the disk which is removed minus this effect of the disk is to be removed from the complete sheet. This is the complete sheet minus this, you will get this. Are you getting? So electric field P is nothing but electric field due to the sheet minus electric field due to the disk. Disk portion you have to remove, and when you will simplify, this is sigma upon 2 epsilon naught 1 by root 2, right? It is cancel out. So sigma upon 2 root 2 epsilon naught is the electric field at this point P. Is it clear or not? So in this way, if you remember the formula, if you remember this formula, you have to write the electric field directly, right? Copy this. So the next one more question this type, or you may write the electric field you have to find due to annular disk. Annular disk mean not the complete disk. Suppose this is the big disk and a small disk is cut out, right? And here the electric field is removed. The electric field you have to find due to this disk. This portion is removed. The surface charge density is the sigma coulomb per meter square. The inner radius is assumed to be the A and the outer radius is assumed to be the B, right? This is A, this is B. You have to find the electric field at distance x. Is it clear or not? Find the electric field due to the annular disk on the axis, right? This is the question. I think you can think. Copy this first. How to solve this question? In the same way we have done previously and directly formula. Suppose this is the complete disk of the radius B, outer radius is B, and this is the surface charge density. Is it clear or not, you tell? So because of this angle assumed to be the theta 1, all right? This distance is x, suppose. Are you getting or not? So what is the electric field E1? Is sigma upon 2 epsilon naught 1 minus cos theta 1. Are you getting? This is the basic formula. Now, if you consider the small portion whose electric field is to be subtracted, the radius is A, the surface charge density is the sigma again, sigma coulomb per meter square. Fine. And this is the point, all right? And this angle is assumed to be the theta 2. This distance is x, this distance is A. So because of this small portion, small disk, this is complete disk, this is also complete disk. The radius is B, radius is A. The electric field due to this is what? Sigma upon 2 epsilon naught 1 minus cos theta 2. So to find the electric field due to this annular disk at this point, what you have to do? You have to find first the electric field due to the complete disk and just remove this disk from here and it will form. So what you have to do? You have to subtract this electric field E2. Then you will get the electric field at the point P is nothing but E1 minus E2. Is it clear or not? This is the simplest way, right? Otherwise, you have to assume the elementary ring, then you have to integrate. But if you know the formula, you can write it directly. So the E1 is what? Sigma upon 2 epsilon naught 1 minus cos theta 1, sigma upon 2 epsilon naught 1 minus cos theta 2. So sigma upon 2 epsilon naught, right, 1 minus cos theta 1 minus 1 plus cos theta 2. This cancel out. So sigma upon 2 epsilon naught cos theta 2 minus cos theta 1. So this is the electric field at point P. Right, I am writing this side. Anywhere you can write sigma upon 2 epsilon naught. What is the cos theta 2? It is root over a square plus x square. So cos theta 2 is base upon hypotenuse minus, this is the b, this is root b square plus x square. So what is the cos theta 1? Base upon hypotenuse, b square plus x square, right? So if you take the x common, so 1 upon root a square plus x square minus 1 upon root b square plus x square. So this is the electric field at this point P. I think this is the easiest way. Otherwise, how to solve this? You have to assume at distance r the elemental ring, right? This is the elemental ring, and because of this elemental ring, you have to write the elemental electric field. Then you have to integrate. That is the very lengthy process. So you can apply this shortcut, right? Copy this. So now we can discuss the force on charge in electric field. Right? Although we have defined the definition, we have defined the electric field is nothing but force per unit charge. Is defined as the electric field. The force on the charge placed an electric field is nothing but Q into E. This is the vector form, or the magnitude is Q into E. What does it mean? Suppose this is the electric field over there, right, like this. The electric field is like this. This is the direction of the electric field, right? So if you consider the plus Q charge placed in electric field, the electric field may be produced due to any continuous charge distribution. You can assume that there is a infinite plane sheet, and due to this the electric field is produced. Suppose the electric field is present by anyhow, so the force is what? Say Q into E. If the charge is positive, the force is Q into E. You have to remember in the direction of the electric field. But if the charge is negative, the force will be Q into E, but the direction of the force will be opposite to the external electric field. You understand or not? Right? For positive charge, for plus Q, right, the force is along electric field, right? For minus Q charge, right, the force is opposite to electric field. You understand or not? In both cases, the magnitude of the force is nothing but Q into E. Q into E, you have to remember, right? So this formula is many times used, right? Let's see some example. First, copy this. So how to solve this problem on the basis of this? For example, suppose this is the infinite sheet. The infinite charge sheet is placed horizontally like this. Is it clear or not, you tell? Right, this is the infinite, till infinite, till infinite. Although this plane sheet is placed like this horizontally up to infinity, it is extended up to infinity, right, like this, like this. The surface charge density is sigma coulomb per meter square. Just below this, if you consider the charge particle is Q node, right, and its mass is what? M. Is it clear or not? The distance is assumed to be the d, right? For equilibrium of Q node, the condition for equilibrium of Q node, right? The question may be asked over there. You tell me how many force will act upon this. If the mass is m, the mg will be acting vertically down. Is it clear or not, you tell? So if this is the charge, suppose this is the charge, if you leave this, it will fall down because of this mg, but the charge is q naught over here, and this is the surface charge density. Because of this surface charge density, the electric field, this d you can leave, right? The electric field will be produced, right, in the vertical upward direction. Is it clear or not? If this is the electric field E, what is the electric field value? You will say sigma upon 2 epsilon naught in the vertical upward direction. So therefore, in this direction, the force will be equal to what? QE. Force Q naught E will be acting over here. Condition for equilibrium of Q naught is that the gravity force is balanced by the electrostatic force. Is it clear? Right. So what should be the value of the sigma? Right. They may ask any question. I'm just writing the expression. The electric field is nothing but sigma upon 2 epsilon naught. So what should be the mass? Or they can ask the sigma. The mass should be equal to Q naught upon sigma 2m 2g 2 epsilon naught into g. So it should be the mass, right, of the charge particle, so that it can hang in the air because of the gravitational and the electrostatic repulsion, right? Do you understand this question? Right, copy this. Let's do one more illustration. Suppose this is the sheet, the infinite sheet again, right? And having the surface charge density is plus sigma coulomb per meter square. There is a bob of the mass m, and the charge is on this q. The string length is L. Is it clear or not? So listen one thing. When initially it is at rest, the mass, right, when it will be hanging, so because of electrostatic repulsion, the force, the mg will be acting in this direction, right? And because of this, the QE force will be acting in this direction, right? If this is the length and this is the angle theta, right? In equilibrium, I'm writing in equilibrium, right? Find the angle theta with the vertical as shown in figure B. In figure below, right? Copy this. So if this is not the line charge, I am explaining this is the sigma coulomb per meter square, and the electric field will be away from the sheet, right? Like this. Everywhere it is constant, does not depend upon the distance. The electric field is sigma upon 2 epsilon naught. Fine. If it is in equilibrium, the mg will be acting in this way. This is the QE. This is the tension. Suppose this is the angle theta. This is theta. This component is t cos theta. This component is t sin theta. If you assume this is the x and the y direction, so in x direction, the t sin theta is balanced by the QE, and the t cos theta in y direction, it is balanced by the mg. This is the equation number 1 and 2. If you divide 1 and 2, so t sin theta divided by t cos theta must be equal to QE upon m into g, right? So the tan theta is equal to what? QE upon mg, and q upon mg. The electric field is what? Sigma upon 2 epsilon naught. So the theta you may write tan inverse sigma upon 2 mg epsilon naught, right? This is the angle made by the string with the vertical, right? So in this way you can solve many questions, right? Copy this.